The topic of this video is writing rules for sequences. There are two different ways to write a rule for a sequence. You can use an explicit equation, which is an equation for a term in a sequence that determines the value of any term directly from n. So basically that's saying I want to know term 5, so I'm going to plug in the number 5 into the equation and it's going to give me the output, the term. A recursive equation is an equation for a term in a sequence that requires knowing other terms in the sequences first. So it's like a generator. You have to know the first term to know this next term because you're going to keep doing the same operation to develop the sequence. Let's take a look at some notation that's going to be needed when you're writing the rules. Sequence notation, especially when you're writing recursive rules, you'll need to use subscripts. So let me just define some of the subscripts that we're going to be using. One of the subscripts that we're going to be using is T sub 1. And basically what this means is the first term. The other notation that you're going to need when working with recursive rules is Tn minus 1. And basically what that means is previous term. Now you're not actually going to be plugging anything in for T of n sub n minus 1, but you're just going to verbalize it as previous term. Now let's take a look at the different types of sequences, arithmetic and geometric, and writing an explicit and recursive rule. Arithmetic sequences and writing rules. First off, remember that arithmetic sequences either add or subtract. To write an explicit rule for an arithmetic sequence, it's going to be T of n equals D times n plus T of 0. Okay? Now, D means the common difference. What that means is, what are you adding or subtracting? T of 0 is the 0th term. Okay? To write a recursive rule, you're going to need to know the first term, and then you're going to tell us how to find the next term. So you're going to find the next term is T of n equals your previous term plus your common difference. Okay, so that D means your common difference, what you're adding or subtracting. So here we have an example of 18, 29, 40, 51. We're adding in this case because the sequence is getting larger, and we're going to find that pattern or the common difference, and it's going to be adding 11. So now to write the explicit rule, I'm going to start off with T of n equals my common difference, which we found to be 11 because that's what I'm adding, times n plus, now I need term 0. Whenever you're given a list of numbers, the first number is always going to be the first term in the sequence. So I'm actually going to need to go backwards to find the 0 term. So I'm actually needing to do 18 minus 11, and I get 7. So here is my explicit equation for this sequence. Now if I wanted to know the 50th term, I could simply take 11 times 50 plus 7, and that would tell me what the 50th term would be. Recursive. The first thing I would need to know is my first term. Remember that the first term is the first number listed in your sequence, so 18. Then this part of your sequence, the T of n, Tn minus 1, that part is going to stay consistent. You're always going to be writing that when you're writing a recursive rule. So I'm going to go ahead and continue that. So T of n equals T of n minus 1, meaning to get to the next term, I'm going to take the previous term and my common difference, which is what I'm adding or subtracting in the pattern. So I'm going to add 11. So what this means is to get to, let's say, the second term, I need to take the previous term, which is 18, and I'm going to add 11. And you'll notice that that is 29, which is the second term in my sequence. Now, I would always need to know the previous term to generate the list of the sequence. So a recursive rule, this is challenging if I wanted to find the 50th term, right? I would have to sit there and add 11 50 times. So there's a benefit to each different type of equation. Let's take a look at how we would write rules for geometric sequences. Remember, when you're writing rules for a geometric sequence, the pattern type is multiplying. Okay, no dividing. It's either multiplying by a whole number or multiplying by a fraction. Okay, when you're writing that explicit rule, it's going to be T of n equals your T of 0 times your common ratio raised to the nth power. Okay, so this is going to be the 0th term, and the R means your common ratio, meaning what it is that you're multiplying by, whether that's a whole number or a fraction. To write a recursive rule, again, you're going to need to start with the first term, and then that fun notation that's going to get repetitive. So T of n equals T sub n minus 1, multiplying by your common ratio. So again, what it is that you're multiplying by. And remember that this notation just means the previous term. Let's go ahead and take a look at this example, and let's write both an explicit and a recursive rule. So to write an explicit rule, we're going to start off with T of n equals. Now I need to know the 0th term. This 16 is my first term, so I actually need to go backwards. So I got to figure out what this pattern is. How do I get from 16 to 32 to 64 and 128? I'm simply multiplying by 2. So if I have to go backwards, I'm going to multiply by 1/2. So my 0th term is going to be 8. So I'm going to take 8 times my common ratio, which is going to be 2, and I'm going to raise that to the nth power. Now again, if I wanted to figure out what the 50th term would be, I would take 8 times 2 to the 50th power, and that would give me the 50th term in my sequence. To rewrite a recursive rule, we're going to start off with our first term, which is given to us in the list of our sequence, so it's going to be 16, and then we're going to use that repetitive subscript notation, where we're going to say to get to the next term, you're going to take your previous term and multiply it by 2 as we're using that common ratio. So here's some practice that we'd like you to do. The first one is I'd like you to write the explicit rule for the following sequence. The second question I'd like you to do is use the recursive rule to find the next 3 terms within this sequence.